Hello students, how are you? And we are going to start our next chapter, magnetism. Okay, now you are already familiar with the bar magnet. In previous classes, you learned that it has two poles, north and south. And now we are going to discuss the field due to this bar magnet, and we have to calculate the field due to this bar magnet at some point P. Now the magnetic field of a bar magnet at an axial point, we have to calculate at a point which is lying on the axial, on the axis of the bar magnet. And for this, now let us consider the point P is at r distance from the center of the bar magnet, and the total length of the dipole, that is in magnetic dipole, that is 2L, and from center the distance of the point P is r, and from north pole this distance becomes r minus L, and from south pole this becomes r plus L. And we have formula to calculate the magnetic field at that point. It is given by mu naught upon 4 pi m upon r square. Now to calculate the total magnetic field at this point, we have B axial equal to V1 plus B2, and this V1 acts along this direction and V2 acts along this direction due to north and south pole. Now the value of V1 is given by mu naught upon 4 pi m upon, now distance of the point from the north pole, it is r minus L whole square, and this acts along px in this direction. Also B2, it can be calculated by formula mu naught upon 4 pi m upon r plus L. Now this whole distance, this is r plus L square along Pn, this direction. Now it is clear from the data that is V1 is greater than V2 and in the opposite direction, so we can conclude that total B axial equal to V1 minus V2. And now we have to calculate by putting these values here. We get this. Now m becomes common, mu naught upon 4 pi m, and by taking LCM we get r square minus L square whole square, and by opening these squares here we get r square plus L square plus 2rl, and this whole term r square plus L square minus 2rl, and the sign changes due to outward sign, so we get minus r square minus L square minus 2rl, and this r square and L square with opposite sign cancel each other, and we get 4rl. Clear? Now by splitting this 4 into 2 into 2, and this m goes to here and r here, and now this 2ml, put 2ml equal to m is magnetic dipole moment. It is distance between poles into either pole's distance. So it is, we get, so by putting this value we get V axial mu naught upon 4 pi 2r m upon r square minus L square. Now for short dipoles, if this dipole is very much short as compared to the distance, of the point of observation, then we have L very less than R, and we can neglect this L square. So by neglecting this becomes R4, and this R4 and by cutting and calculating we get V equal to mu naught upon 4 pi m upon r cube. This are related to magnetic field at a point on the axis of bar magnet. And in our next topic, we will discuss the field on the equatorial point of a bar magnet. Thank you.